Well, maybe.
They didn't call me and tell me that my book was in until Saturday, so I'm picking it up today. If I need it for this class.
So we're going to discuss a few things today that are in the first chapter. But what I would encourage you to do is, when you get your book, go ahead and just read that chapter so that it'll have some additional information. I mean, that'll be helpful. Okay, so the main thing, we're a little bit behind due in large part basically to this coming in so late. But we'll just make some adjustments along the way to deal with that. Okay, so the main thing I wanted to do today is basically an overview or introduction to systems analysis and design to hopefully set the stage for many of the things that we're going to be doing in this course and implementing in this project with our client who will be visiting on Wednesday.
We need to be present in any way for them when they're just showing up?
This time around, so for Wednesday, I think as you are is okay. But for the presentations, yeah, definitely you want to be dressed up for that. Okay? Question?
Are these online? These slides? Are they online?
These are just posted this morning, so they are online.
Okay.
And I'm recording this with Integrity right now, so this lecture will also be on there as well. Okay. All right, so we'll provide a broad overview of the software development lifecycle, SDLC. We'll talk about a few of the systems methodologies that are discussed in this chapter and look at some of the strengths and weaknesses of each. But again, although we've already decided, I think we've talked about we're using the unified process for this particular course, it is instructive to actually know what other methodologies are out there that you might encounter with companies that you might work with. We want to be conversant in that kind of discussion, but two, to also be able to, should you need to actually engage in one of those methodologies, actually be able to hit the ground running, at least have some overall concept of what it actually entails. We'll talk very briefly about what systems analysts actually do. Hopefully give a little bit of RJT, a realistic job preview. And then get into a little bit about these object-oriented systems and UML, which is a lot of what we're going to be doing this semester. All right, so just a few questions I think that are worth thinking about and talking about to at least get our discussion going about software systems development. So what do you all know about the software or the system development lifecycle? What is it?
The entire process of deploying an application.
Right, so it is that entire cycle that encompasses the involvement of a system from the initial inception of the idea to the very end, which is the system that actually gets delivered at the end. And so what are some of the parts or the phases that make up this life cycle?
Is it the planning, analysis, and design and implementation?
Exactly, right. So those are typically the four main phases that you see in any development life cycle, right? So there's a planning phase that comes at the very beginning, right, and that feeds into, it has outputs or deliverables that feed into an analysis phase. The analysis phase then has some set of activities and things that culminate in deliverables for the design phase, and the design phase then provide inputs into the implementation, right? And the output of the implementation then is that final system that gets put in place and is deployed. So what types of activities then do you think are involved in it? You know, when you talk about...
Can you repeat what the phases were? Planning and...
What's going on here? Right, so there were planning, analysis, design, and implementation. So what types of activities do you all think are involved in each of those? Let's take the planning, for example, which is a lot of what we're going to be doing. What does the planning phase involve? What types of things are included in that?
Gathering requirements, what you need to be doing, or what they're asking of you.
All right, so you want to have some idea of what they're actually asking of you. What type of system do they want in the end? What type of function do they be doing? What are some of the main functionalities? Other things? All right, so once you start getting into some of the project management aspects of this, the planning, you want to know exactly, you want to have a sort of plan of execution, right? You want to have a plan of what resources you're going to be able to devote to this overall undertaking. Especially typically with these systems, you talk about millions of dollars involved. With bad planning, a lot of money can go down the drain, so it requires a fair amount of brainstorming at the beginning to actually have a plan of attack. Are there any other things that you think might be involved in this phase?
Determining the scope of your project?
That's absolutely critical. This perhaps is one of the ones, at least as far as how much money gets spent, is the one that potentially, if it's not managed properly, can actually create a lot of problems. Right, so you have to be able to scope the project. Inevitably, you're going to get scope creep. This is something that happens a lot, right? So it starts off as an idea of a very simple system that's going to do X and Y, and over a series of meetings and discussions and perhaps even presentation of prototypes and things like that, the types of things that then get requested just naturally starts to increase. It's like, oh, okay, that's sort of nice, but it would also be nice if it could do this. Oh, yeah, that's nice, but it could also do this. And before you know it, a system that was supposed to maybe accomplish 2 or 3 very simple things now is required to accomplish 10 different things. Right, so scoping the project and understanding the scale of it is absolutely critical. Okay? This also ties into how much money gets devoted to this. Right, you're talking about person hours that are devoted to this. You're talking about various technology resources that are being put into this, be it servers, databases, things like that. So you absolutely have to be able to actually scope the project and have a sense for what it actually needs financially and in terms of other resources as well. Okay? And some of these methodologies, as we'll discuss a little bit later on, actually have different implications for how you're actually going to manage things like scope. Some tend to be very restrictive, others actually fairly organic in the sense that they the scope can change as things go along, as needs change as well over time. And some methodologies are actually fairly aggressive as far as how they actually embrace that. Okay, so what about the analysis phase? Yes.
You get a sense of what the client needs done. What their business is.
So those are 2 critical parts, right? So going off of the planning phase, which is sort of a broad conception of the system, then once you get into the analysis phase, they're getting a little bit more into the details of what needs to be done, right? You're getting into a little bit more of what some of the key processes are, some of the key functionalities are going to be, and analyzing those to get a sense for, and perhaps even looking at what the actual practices are, right? You probably hear this referred to as the as-is model, right? So you're trying to get a sense of how things are actually currently done. And then through a series of discussions and problem solving and brainstorming, you might come up with some ideas of what the new process would look like. What changes might come about in that process as a result of actually having a system in place. Right, so part of what precedes that then, in order to be able to link this to the previous phase, is that you want to have a good sense of the current phase for what the value proposition is for the system, right? So we don't just build these systems for kicks, right? There ultimately is some objective. So you have to create a value proposition. And so part of the planning process is to say, well, why do we need the system? If we have the system in place, what benefits do we actually expect to see as a result of this system? Now, typically, in your for-profit type of establishment, that's going to translate into actual monetary value. Right? It's going to help us improve our profitability in the following ways. Maybe fewer defect rates, which means we're spending less money sort of fixing problems for our customers later on. Perhaps it's going to help us expand our market share. There's got to be some sort of value proposition and some way of actually linking where within that process the system is actually going to help facilitate that increased profitability. Now when we talk about government agencies or not-for-profit, obviously then the value propositions are not necessarily so thought of in terms of profit, but perhaps in terms of things like savings, efficiency, effectiveness, right? So, for example, we're able to process specific requests a lot more rapidly, a lot more efficiently. So those are some of the things that you need to think about. And those then would feed into the specific business processes, so understanding what the current process looks like. That'll probably allow you to identify where some of the problems are in the existing processes that the system can then be used to address. Any other thoughts on what types of things might be done in the analysis phase?
What about feasibility? Where does that fit? Does that fit in the planning or analysis?
That's a very important one. So the feasibility typically would also be in the planning phase. Right, so this is before you actually launch the project, right? And they're typically you want to know if it's technically feasible, right? So can we actually do this? Do we have the technical capabilities to actually do this, and the technical resources to accomplish this? And typically there are a variety of ways of going about this, right? So on the one hand, you may have an in-house information systems department that actually has the expertise, right? They have developers, systems analysts on hand to actually do this. In other cases, perhaps what's needed is so specialized that you don't necessarily have that expertise in-house. In which case, there are other possibilities, right? So one is outsourcing. How many have heard of outsourcing? I'm sure you might. Yeah, okay. So what's outsourcing? Somebody just give us a quick.
It's just hiring someone outside of your organization to complete an assignment or some task or maybe a piece of the code that you're going to have to do.
Exactly, right. So typically, if you don't have that expertise in-house, you can go to some other external third party who actually has that expertise, right? And they can bring their expertise to bear to help you on that component or wherever pieces of expertise you might be missing. They can provide that in some form or fashion. Okay. Another form of this would be offshoring, which is basically another form of outsourcing. Who all here has heard of offshoring? Everybody give us a sense of what offshoring is?
We utilize offshore as far as we have programmers who do work in India, and they do development at night. They do coding, so we work pretty much 24/7. And then those guys, do development during the off hours. So they'll work with maybe a merchant who does that also. A lot of the merchants that we work with have offshore contractors also.
Excellent. Keith, I think you've also worked with done some offshoring. What types of things do you find yourself sort of involved in or doing as far as offshoring is concerned?
It's pretty much all tasks that can be detailed specifically. So not necessarily, pretty much all of like the thinking and creative tasks are done onshore. And then all the offshore tasks are extremely detailed in what they do. Most of it is just the programming.
All right, so there are a couple of things there that are typically important when you're making this type of decision. One is, and it's a very important one, it's the type of work you decide to outsource, right? So not just the expertise domain, there are certain aspects of the development that could be done fairly straightforward, and you can get this round-the-clock development to actually get the system in progress a lot quicker and for a lot longer in terms of the period of time that you're actually working on it. Right, so if you think about it, you finish work here in the U.S. at the end of the day. You might set out a set of tasks that need to be done. Whatever that is, that can be detailed very clearly, then gets shipped off to the next offshoring site, be it India or some other place. And so while we here at the U.S. have finished our workday, that work has been processed over in India. So by the time we get to the next day, whatever needed to be done at the time that we finished work then has been completed the next day, and we can essentially go back and review it and see what needs to be done and move on from there. All right, so part of it is what helps with this round-the-clock development that can also help create some efficiencies, but it also has a potential to do two other things, which is one, offshore or have work done on aspects of the code that are fairly easy to describe and therefore perhaps not as creativity intensive, which then allows folks on site to actually focus on the things that require a lot of the heavy lifting, right? So a lot of the creative work that one requires somebody who's typically co-present here who has a good idea of what the processes are and how things are done. Okay, so that's another aspect of what's important when you're looking at this feasibility. What is the other type of feasibility? So we talked about technical. What other aspects of feasibility do you think would be important? Financial, right? Can you actually afford to do this? What are the potential costs associated with this? Obviously not going to be able to map out and anticipate a single cost, but having a good sense for how much this is going to cost is going to be important, because it will ultimately inform whether the sponsors of the project are willing to actually move forward with this or not. Any others? If the textbook talks about this organizational feasibility, does anybody know what that is? This organizational feasibility.
So, I guess if the organization has the kind of like protection to take on the job and have the resources available.
And then, right, so that's the beginning part, and then what follows from that? Not just for Scott, I mean just generally. What do you think would follow from that if we have sort of the capability to put something like this in place?
To maintain the database, or whatever, like to maintain the project, like keep it going, do they have the resources for that?
And that's important. So there's the long-term aspect of this. Once the system is in place, if the maintenance, any system enhancements that might go along with that. So that's another aspect. But so the important part of the organizational feasibility, in addition to what you all have said, is also the idea that this is something that will actually get used within the organization, right? So sort of the sense that if you build it, will they come? Is it going to get used once you have the system in place? Obviously, for all the money spent on building a system, it's practically useless if it actually doesn't get used, right? The value comes when it actually gets used by the intended users. So you got to make sure that it's something that will indeed get used. Okay, so then we talked a bit about the analysis phase. What follows then is the design phase, and what do you think some of the activities there might involve?
Talk the system will operate, like in terms of the hardware they use, the software, and the network architecture, and all that.
Exactly. Everybody get that? Right, so this is when you're actually getting into how the system itself is going to operate. So you get into some of the technical details. What's the specific platform? What is the underlying architecture going to look like? This is where you start actually getting into a lot more of some of those technical details of the actual system, including mapping out then many of the processes in terms of models, perhaps even creating prototypes of what this thing is going to look like. Okay, so following on from the analysis, then you're getting into a lot more of the concrete aspects of the system and what it's going to look like. Okay, then the implementation. What happens with implementation?
Testing. Some sort of testing.
Right, so testing is a very important aspect of this. Tends to get to be highly underrated, but is extremely important. Anything else in addition to testing?
Monitoring.
Sorry, what was that?
Monitor.
Oh, monitoring. Yes. Yeah, absolutely, absolutely right. So monitoring is going to be extremely important, especially once you actually have the system up and running in some form, right? You want to make sure you monitor the performance and how it does, and some of that might fall into part of the testing cycle. As you're testing, obviously, you're assessing things like the reliability of the system and things like that.
You document also during implementation.
Right, so documentation, different methodologies will have a different take on how much documentation you do, but that's absolutely an important aspect of it. One, it helps create essentially a written history of the system, how it's designed, how it operates, and things like that, but it also provides for the long-term maintenance. It's something that future developers can go back to. And this is particularly important when you think about the long-term implications. Putting all this money into the system, implementing the system, what happens when all the developers who just through natural churn, they're going to go off and get other jobs, do other things? What happens when those developers leave? Right, all the knowledge of the system goes with them. And so documentation provides some concrete, permanent place where you can actually store that knowledge and information. So documentation is absolutely critical.
Training for users.
Training for users, very, very important. You could easily do an entire course just on the importance of this particular aspect of things, because this training could easily be the thing that makes or breaks the success of the system. Even if the system is technically sound, it actually works. It does what it's supposed to do. If you do not have sufficient user training, the project as a whole could be considered a failure. You hear this a lot with these enterprise resource planning systems, ERP systems. Right? What are some of the... I think we did a short glance earlier about how many of you had heard about ERP systems. But how many of you are aware of some of the issues associated with implementation of these systems? Anyone?
Enterprise's resources might change from day to day.
Right, so they can change. Okay, it's just nature of sort of the business cycle, nature of business, right? Things can change. Along with that, one of the main challenges when you're implementing these types of systems is that they fundamentally change business processes. Right, so you hear that thing, systems like SAP, Oracle, all of these systems typically have best practices embedded in them. And what this is basically as a result of much of the consulting that they do when they implement these systems, is they get a sense of what the best way to execute typically generic types of processes are. So, for example, processing purchase orders. What is the process for actually processing a purchase order? There's sort of the best practice for that. If you're processing a customer order, there's a best process for that, best practice for that. And that is basically that you can break each of these into a sequence of steps. Each company may do it differently, but overall there is sort of a certain ideal sequence of these steps and associated information that gets processed in each of those steps. So those tend to be embedded then in the SAP system. Now when you implement it, yeah, you can do some customization that makes it specific to how you as an organization do this, but there are costs associated with that. So for example, you're spending millions of dollars just to implement SAP. Once you're done, if you do a lot of customization, what happens when the next release of SAP comes in? Well, guess what? All of that customization goes out the door and you have to do it again. It's more millions of dollars. And so that's a lot of how SAP and a lot of similar ERP software systems actually make their money. It's not so much on the initial installation; it's the long-term services that go along with that. Right. So if this is when I taught this to master's students in Arkansas. That we had Tyson. How many here have heard of Tyson Foods? Okay, so Tyson Foods headquartered in Northwest Arkansas. And so one of their things is, specifically when they're dealing with things like they process a lot of chicken. Chicken is not the only thing they actually do. It actually tends to be one of the smaller parts of the market, but it's the one they're most well known for. With SAP, they run SAP, and so with SAP they have to do some customization, particularly in accounting for the basic unit of their product. So take the example of chicken. Right, so with chicken, with SAP, you can actually account for units either by the unit, so how many things you actually have. So you might think of it in terms of how many individual chickens you actually have, or you could account for them by the weight, like overall weight, how much sort of chicken are we processing. Tyson in particular had a very unique issue that they had to develop a custom solution for because it wasn't embedded in SAP. And that was to account for chicken not just by the unit or just by the weight, but by a combination of both, because obviously there's value attached to each unit, each chicken, but also by the weight because each chicken varies by weight. They're not all the same weight. And so this is a particular customization that they actually had to implement. Problem is then every time they upgraded their version of SAP, that customization will need to be done again, right? Because it's not embedded in the new installation. Okay. So these are all very important issues when you talk about customization of the systems. How that ties back into this training issue is fundamentally, if you're not doing customization, you're having to retrain people on how to actually execute their jobs. This tends to be the number one fear for users of a system, and one that probably, outside of actually developing the system itself, is probably the biggest challenge that is associated with developing systems. While you develop a system and you're going to plug it in and you're going to say, well, this is fundamentally going to change the way you actually do what you do. Now that means people have been doing something for, decades in a particular way and have gotten very good at it. And perhaps have become expert at their particular job. May now find that aspects of their job are either automated in the new system, which makes their unique advantage obsolete, or that it just changes things so much that they, through no fault of their own, may feel perhaps somewhat incompetent in the new system, even with the same job. And so that's something that's absolutely one we got to be sensitive to as builders of these systems, but also two that we have to overcome, because otherwise one that results in the things that we fear, which is one, the system doesn't get used, in which case that's money down the drain, or two, we get active sabotage from employees who don't want to use the system because it is a threat to how they do their jobs. Okay, so the user training aspect of things is you just cannot overemphasize its importance in this process. Well, fortunately for us in this class, it's not something we're going to have to deal with, but it is a very important aspect. Okay. Okay, so we just talked about this is the overall system development life cycle. Within that, we have system development methodologies. Now, what are those? What is a system development methodology?
A specific way of going about those phases.
Right. So that's a very good way of characterizing it. Think of it as the sets of steps or the approaches to actually going through that life cycle we just talked about. Right. So each system development methodologies, think of it as a set of practices or approaches that are used to go through that cycle. It's going to approach that planning, analysis, design, and implementation in somewhat different ways. Okay, and so I think that first chapter talks about different types of system development methodologies, and so we'll talk about a few of those here very quickly. Right, so these actually fall, you can almost think of them as falling along a continuum from very structured to very organic. Anyway, so some of the structured elements of this, one that perhaps is one of the ones that started it all as far as formalized methodologies would be the waterfall method, and you'll see this in a lot of companies even today. So this waterfall methodology essentially takes each of those steps that we talked about and breaks it out into specific sort of standalone phase of the project. And typically, but not always, these would be sort of a feed forward in the sense that you engage in this planning phase and produce some documentation, be it the system request and other things. That would feed into the analysis. The analysis outputs then would feed into the design and then into the implementation. But you very rarely have sort of these feedback loops that allow you to go back from the analysis phase to the planning phase. Now, there are some variations of that actually allow you to do so. Typically what you see is that there's this planning phase, months and months go by where we're just planning and sort of figuring things out. And then once we're done with that and move the analysis phase, we very rarely ever come back to this planning. Right? That's done, it's set in stone, and we move on. And the way that relates then to the project scope, which was mentioned earlier, is that typically then they try to keep the project scope very fixed. Which means that it's fairly challenging then, if anything changes a lot of this along the way, to actually go back and implement new changes in the project scope. An alternate one is this parallel design, or parallel development. That's also talked about in the textbook. In essence, a lot of this is broken up at the design phase, right, where you do the initial planning and analysis, and then you break the problem up into smaller components, right? So you can think of these as subsystems. So you might break it up into different subsystems, where you do the design of the subsystem, and then the implementation, you actually develop the code for that subsystem. And then you engage towards the end, once the subsystems have actually been built, you've done the coding, the testing, and everything else, you want just to integrate all of those subsystems together. Which can be, if it's not managed well, it can be a huge nightmare of the process to actually manage. For one, because if it's not properly managed, you might have different programming standards that might be used. You might use different platforms in these subsystems. So if you're going to do something like this and do it well, you want to make sure there's careful coordination across the development teams that are actually building these different subsystems. Make sure that they're using the same standards. Make sure you have agreement on specific platforms that are being used. That way, when you get to this integration phase, it's easier to put these pieces together. So that these systems work in tandem with each other and present hopefully consistent interface to the user. So for the user, it looks like just one single system. Two, that the coding standards are the same, so that when we do the integration, obviously you have to do some work to make sure these pieces fit together. That everybody has an understanding of the naming conventions, of the structure of the code, data types, and things like that as well. All those are critical steps that will determine how well this integration gets done. Right, then the integration then will lead to, once it's successfully completed, final system being delivered. Okay, so that's one set. It's a very structured design. Everything is in a very specific phase, and once you go through one phase, you rarely go back to previous phases. Another class of approaches is referred to as rapid application development phases. Right. So this is an approach that tries to speed up the process of actually delivering a working system. In contrast to these previous approaches, which typically take a lot of time in the planning and analysis phase in particular, where the emphasis is getting some version of the system out. Now, typically that means that in terms of functionality, it's fairly limited. But at least you have some working system upon which you can basically add additional functionality. Right, so in this phase development, you go through this initial planning and analysis, and then you basically prioritize the key functionalities, right? So the things that you absolutely as a business cannot live without are the ones you prioritize first. And you set about the process of actually developing that functionality first. Right, so that results in an initial version of the system that is a working system that can actually be used. Meanwhile, you then use that system as a baseline for developing the next set of required functionalities, right? Which allow you to then build in the additional and improved functionality for the system. And you sort of see this then going into the next phase where you're incrementally sort of adding additional functionality to the system overall. So it's another way of approaching this that is a little bit more organic than the structured design, in the sense that one, you focus on the most important needs first, and then you sort of build in additional functionality. It also means that a system gets out of place and into use a lot more quickly. Prototyping is another one. Where typically you do the initial planning and then do a lot of the analysis, design, and implementation to actually create a prototype. Something that gives an indication of what the system would actually look like to the user. And then you use that as a basis for getting feedback from the user about that system and how it works. That further informs many of these processes. So you can essentially engage in feedback loop here until you get to a prototype that is agreeable with your customer, the end users. Once they're happy with that prototype and have a good sense for how it's going to work, and they're satisfied with that, then you go to the actual implementation where you provide the functionality behind it. Okay, so just another way of going about this. I think the throwaway prototyping is another one where decouple this from the implementation. You sort of use this to come up with a workup of how the system would work, but then once you're okay with that, you engage in separate design of the actual system itself and implementation. Okay, and then finally, the sort of last broad class of these are at the extreme end, perhaps the most organic. Collectively, there's a set of these that are referred to as agile development practices, of which there are a variety. You probably you hear about XP is probably the more well-known one. Extreme programming. Scrum is another fairly well-known one. Feature-driven development is one you hear a lot about as well in a variety of places. The test-driven development, or TDD, would be another. And a variety of other ones as well. So what's different about these is they fundamentally take this concept of developing systems and emphasize actually meeting and being responsive to user needs. So they take the user as essentially the central focus, and the user needs as the central focus. And much like the rapid application development process, they focus on basically going through iterations of development, where sort of outline key releases of the software. You basically prioritize the specific functionalities that are needed so you can actually produce a working system as early as possible. And so there are a variety of processes associated with that. So the release plan, typically it varies from place to place, but the typical standard I think would be about a 3-month cycle, so 90 days for release. Have an iteration plan that sort of breaks us out into each week as to what needs to happen, what are the key functionalities we're going to produce. Acceptance tests, which typically derive from what are called user stories. So you see things like user stories mentioned here, which think of those as requirements for the functionality of the system, what things need to be done. And what you typically see with these, somewhat of a different way of thinking about the process, is they'll have a big open space where developers and client representatives actually can work together, where they'll have these stand-up meetings. And typically with these, you'll have user stories that are outlined on index cards or something similar to that. That could be sort of laid out on the board. And so folks can sort of work together to prioritize functionality. They talk about what happens in what order. And that gives the developers a sense for what actually needs to be done. How to focus on that. Okay, so these acceptance tests then are written by and executed by the clients. All right, it's separate from these unit tests. This unit testing basically makes sure that the software itself actually executes the way it should. But that's separate from acceptance tests, which is, does the system as developed actually meet user needs? Does it do what the user actually needs it to do? So user involvement tends to be fairly heavy in this type of methodology. Okay. And there are a variety of other practices that are fairly important in this. Continuous integration is one. Making sure that as you add new functionality, that it is obviously well embedded within the overall system. But two, then the refactoring, which is trying to keep the system design as a whole as simple as possible. That makes it a lot easier to actually make changes along the way, which is something that this kind of methodology is very aggressive about. It's very aggressive about actually accommodating changing requirements. So if someone comes back later and says, well, we needed to do this other thing. If you keep the design simple, it's really not that difficult to sort of create this additional component that can plug into the system. It gets a lot more difficult to do if you have a very complex system. Another approach, and this is fairly controversial, or has been in the past, is this pair programming, right? So typically you have this kind of methodology would say, well, rather than have one developer go off and write some code, another developer go off and write some code separately, have two developers actually work together, co-present. Typically, you'd have one coder actually writing the code while the second person is looking over your shoulder in a way. But you get engaged in an ongoing process of strategizing about how to actually write the code. And perhaps one of my favorite innovations to come out of this pair programming is I didn't actually believe they'd do this. There is a design out there for the pair programming chair. So you really get to know your coworkers this way. Okay, so that's one. The other one is Scrum, which I believe, you probably work with a little bit. So you can just describe a little bit about what you've done with Scrum, what it involves.
We typically, at the beginning of every day, we'll have a stand-up in which you discuss the three things, like what you accomplished yesterday, what you're going to accomplish on that day, and then any barriers that are in the way. And then the leader, like the Scrum Master, tries to support all the developers by removing the barriers and seeing any other way that they can support all of their developers. Typically in 2-week iterations or sprints. So like one smaller project should be completed within 2 weeks. It's also divided up into tasks, and the developers actually choose the tasks that they're going to do. So they'll take a project and then break it up into different sections, usually about 8 to 16 hours of work. And they'll say, all right, I'll take, task 1.7, and the other one will, all right, I'll take 1.4, and then they'll all just combine at the end of that iteration.
Very good. And that's, again, the aspect of this that's fairly organic, if you think about it, is that folks will essentially take ownership over various functionalities of the system, as Keith just described. Right? And so it essentially leaves itself open to the potential for new requirements to come in or existing requirements to change. And then based on the planning needed for the sprint, to sort of prioritize what some of those functionalities are going to be. And then everybody goes off and pursues or develops the aspects of the code that they're responsible for. And through that, there may be some feedback where they identify perhaps additional requirements or things that might be thought about differently in the system, in which case it provides sort of a feedback where you can sort of come back and revisit what needs to be done in the system. So these tend to be at different extreme of this continuum. Okay, so why don't you take, let's make it 5 minutes, just in your groups. Don't worry about this for now. Just give it where we are with time. Also need out, but think about and talk about these two. Given that we just talked about these different methodologies that are available, and then we'll come back and discuss it more fully as a class. Most importantly, because it's sort of important to think about these. One, because each organization is probably going to have a variety of methodologies that they can use and that they do use. And I would say as you go up the ranks, they're going to come to you as experts on some of these things. As to, most of these are going to be business people. They may not know what these different methodologies are. They're going to come and ask you or rely on your judgment to think about, well, we have this project. How do you think we should proceed? And you want to have some way of actually being able to think about how to approach some of those and sort of think, give advice as to what types of approach to actually recommend based on the project situation. So let's just take a few minutes and just talk about some of these as a group.
How's everybody's weekend? 36
Yeah,
hours.
I know my ability is broken down. I mean, I can try to do
All right, let's do the methodologies right quick. Pros and cons. Yeah. We got waterfall. The first one. Very structured. Pros of that, I guess, would be more straightforward. This program, do this way, do it.
I don't think the project that we're doing is a very large one.
Yeah,
Maybe.
we gotta be extravagant with what we feel like.
You could have like aisle development or
Yeah, we had like 13 different phases for it.
cons for waterfall would be it's not really clear.
It's sort of on its way out.
I have the RAD.
Not creative, and you can't go back on processes. Yeah, it's not very adaptable. I guess would be for a pro. I guess would be considered like the fastest, but it would be the most straightforward. The next one is parallel. So we do systems.
Yeah. Yeah, this one.
What
To be easier to focus more on either one side of that parallel or the other.
So easier to focus, I guess. Easier to manage the overall project. It'd still be pretty straightforward.
It's basically just two waterfalls.
Yeah.
Yeah, the rad, there was two of them, I think, right? No, it was just one. Phase development. Yeah, there was two agile development, one rad, which was phase development. That one's getting systems out fast. Prioritized by functionality. So you do like an initial version of system, like system 1, system 2, and then you keep making adjustments to it. That would be pro of that. You would actually have the finished product fast, I guess. Like you would have a finished product, but then you would modify that product together. Yeah, but you would still have, I guess, if it was a company that needed something quick, and you would see something, I guess.
Again, I mean, it's basically what I thought it was taking one system, splitting it up, apart, and then one team works on one, one team works on the other, and then put it all together at the end. Somewhat what all of them do, but
yeah, that's what I mean. I was thinking it as more of you have an idea of what you need to do. You make a really broad, system of what that's supposed to do, and then you go back, look at that system, and then you go through the process again and kind of make it more like that. I guess make it more functional, and then you take that, once you get that done, re-look at it again and make it more functional until you have it all. What really the con of that would be? I forgot what the con of that would be. That's phase development. There was prototyping, wasn't there? Or was that phase development? What you put down? Okay, well maybe I had these mixed up now. That's what I thought. Gotcha. There's three step prototype. Yeah. My complaint is I would much rather go the figure. Well, kind of that would be previous page. What would con of that be? A lot of going back. A lot of time, a lot of going back, a lot of changing stuff. Where I'm like waterfall, you plan it, you get it done, you're finished. Don't worry about it, don't go back to it. This one you're constantly, these two you're constantly going back, so there's a lot of time.
just one of the agile.
I like dealing with that.
It's one of the disadvantages.
And we got agile development. We have XP, programming, organic. Pro of that is it's very user based, I guess.
They don't know how to build it, right? Finance is a big one either.
Anything else?
And all agile. XP is agile as well.
Do you like coding?
No, I'm doing more of like
It's just like a different. Or you have like a poll or something.
3 days. It was being kind of
Is it on block? I don't think so. I think for us to make up our charter. So I just think I didn't have anything for it. We need comms still for parallel and agile.
They do
System They posted like 3. Would it just be the same cons as waterfall? Oh yeah, they're still really wacko creativity.
I like that. I didn't either. I just thought I'd like.
Yeah.
All right, folks. Let's talk about a little bit about what you all discussed with respect to these methodologies. All right. So, what did you all come up with as far as some of the pros and cons of these methodologies? It doesn't have to be with these. You can start talking about different classes of methodologies. Mike?
I mean, basically, structured methodologies are only good when you know pretty much exactly what you're dealing with, and I mean, there's really no like curveballs. I guess it has to be a really simple project. You have to know exactly what you're doing.
Very important.
The agile methodologies are better for more complex projects, where there's more uncertainty.
Very good. Others?
We came up with basically structured design is more, you only need to really worry about doing it once, and then after you're done with it, you don't need to be concerned with it all that much anymore. Whereas agile development is more, you can go back and fix things and change things over time, make a continuously better product.
Others? Okay, well, let's talk about some of the things you might think about. Under what circumstances would you think about using some of these methodologies? So what types of things do you think might impact, and we've heard some of them already, might impact which of these methodologies you end up using? Obviously, no, none of these methodologies is a silver bullet, right? It's not going to solve all your problems. If it were, then that's all everybody would use. There are pros and cons to each, and each one perhaps is a little bit better suited to specific project conditions than others. So the question is, what types of conditions do you think might affect the suitability of some of these methods?
How fast do you want to get it out?
Okay, so in that regard, which ones do you think would be perhaps a little bit more ideal on shorter time frames versus longer? RAD. So some of the RAD types of things. What are some of the advantages it provides?
Quicker, you get it to product out quicker. user is involved quite a bit.
Find alpha and beta copies consumers test. Last year with no one bugs was the night report problems that they see.
Exactly, right. So that's the advantage when you have a shorter time frame. You want to get something out there that the users can actually, see and touch sooner rather than later. And the issue with some of the structured approaches is that it's such a long period of time before you actually get to some sort of outcome that could be a prototype or something that users can actually play around with. That it makes it perhaps the least ideal in that kind of time frame. Whereas something like RAD or perhaps even Agile would be more ideal in terms of getting something out there that folks can use. They can identify bugs if any, they can suggest improvements if any as well. Any other aspects, project context that might be useful? So we just talked about the time frame as being one important one. Scott?
Reliability.
Right, so reliability is another one that could potentially be important. Right, and so you want to think about the extent to which the methodology that you use perhaps has a good amount of testing embedded in it, be it both from the development perspective, but also from the end user perspective as well.
I was going to say the size and the complexity of the project. Like, if it's really complex, you might use parallel for the subsystems rather than the waterfall approach and things like that.
Yeah, so complexity is another very important one. Right? For the explicit purpose that, or reason that, these more complex projects are obviously going to have many more moving parts, probably going to have more stakeholders involved in terms of organizational complexity. System complexity, obviously, the degree to which there's a lot of interoperability or interdependency amongst various parts of the system itself is going to matter a lot. So that's going to affect, one, the degree to which you can decompose the project into its subunits, but then also whether or not you can use a more iterative approach or a more structured approach to actually develop the system. That's going to inform which methodology you actually think about.
There's a table in the book about selecting criteria for each method, and this wasn't mentioned, but I mean, would your financial restrictions have anything to do? Is one method cheaper than another one?
That's a very good and also a very difficult question to answer. Mostly because it's somewhat easier to do with the structured approach, because you have a very clear scope for the system, a timeline for the system, right? So with the structured approach, like the waterfall, you can sort of say, well, this is the scope of the system. Once we have this set in stone, we know it's not going to change. And so we can sort of lay out, here's the architecture, and that's going to stay fixed. Here are the other sort of pieces that are going to be necessary for this project. And so we can sort of develop a better idea of what the cost is going to be. There's a huge challenge, and companies even now have not come up with a good way of actually figuring out how best to fund some of the more organic types like Agile development. And that, even within research circles, is sort of an ongoing discussion. Because, one, the scope is ever shifting, right? Because it's sort of open to change. The scope at one point in time could be very different from the scope later down the road. So, what exactly are you funding, and on what basis do you sort of fund and sort of create funding for a project? Two, because it's sort of a continuous iterative process where you're doing releases over time. What's the project scope? What's the timeline for the funding? That's sort of difficult to nail down as well. And so, so there's no real sort of answer to that particular question, only because when you look at some of the more recent development methodologies like Agile, there really isn't a good way yet of actually applying some of those financial decisions to this. Whereas it's a little bit more well established with your more traditional types of methodologies. So great question. That's sort of a question that's way at the sort of forefront. There is no real answer at this point in time. A very good one, and certainly one that folks are wrestling with even now. All right, so we talked about complexity as being another one that's very important. Are there any others?
The importance of the function that the software fulfills. If it's in the medical field, it's probably going to be structured as opposed to agile.
Right, and some of that ties in with the complexity as well, but also the importance in the sense that part of the risk, and I think it's mentioned a little bit in the textbook as well, part of the risk with an organic approach like Agile is that because compared to at least the waterfall, some of the more structured approaches, less time is spent on highly in-depth planning and analysis. Getting some of the details down that are very important with these high reliability types of organizations or contexts can get missed out in an agile type of environment. Whereas if you look at the structured approach, so much time is spent on the analysis, really nailing it down, doing extensive documentation and things like that, that it's all basically hashed out for folks to actually see. That can get missed if you're looking at something like an agile approach where typically they tend to shun extensive documentation. They want to get right to the coding and actually producing something that users can actually use. Some of those things can actually get overlooked. Okay, so one other one is then obviously the extent to which you anticipate there be sort of changes in the system. So not just in the scope, but also functionality and the way things get done can impact your choice, right? So if you think it's sort of a stable environment, I think this was mentioned earlier, then it may be okay to go with a structured approach. Whereas if things are constantly going to be in flux, or you don't have a good idea of what the core requirements are going to be, then you want something that's a little bit more organic so that you make allowances for things to actually change over time, or for new things to sort of come up. Okay, so hopefully that would also inform your decisions as well. And then the last thing I'll just say about that is, typically what you see is some form of hybrid, and that's really what this question was trying to get at. Is you see some hybrid form of some of these things. Typically, companies will still be using waterfall, but they may implement something else and create some sort of hybrid form of these methodologies as well. And so it's just something you got to be prepared for. Something that you will see. It's not necessarily going to be sort of clean. We're only going to do agile. We're only going to do waterfall. There'll be some mix of these things as well. Okay, so I just provided this document, this slide to give you an overview of some of what we've been talking about in terms of some of the decisions you might make of which methodologies to use. Okay, so I'll leave it there.